Hello Cloud Gurus and welcome to this lecture. And this lecture is all about DynamoDB. So it's going to be the introduction to DynamoDB. So let's get started. So what is DynamoDB? Well, it's a fast and flexible NoSQL database, and it's for applications that need consistent single-digit millisecond latency at any scale. And it's a fully managed database, and it supports both document and key value data models. It has a really flexible data model, so that means that you don't need to define your database schema up front, and it has really reliable performance as well. And all of these attributes make it a really good fit for mobile, gaming, ad tech, IoT, and many other applications. And DynamoDB is also serverless. It's fully managed and it can be configured to auto-scale. It integrates really well with Lambda, and it's a really popular choice for developers and architects who are designing serverless applications. DynamoDB tables are always backed by solid-state disks or SSDs, which helps to give you consistently fast performance for your reads and writes. The underlying hardware supporting your DynamoDB instance is always spread across 3 geographically distinct data centers. So that means it avoids any single point of failure if one of those locations becomes unavailable. And there is a choice of 2 consistency models for DynamoDB read operations. So the first is eventually consistent reads, and that is the default. And the second is strongly consistent reads. Now with eventually consistent reads, consistency across all the copies of the data across the 3 locations is usually reached within a second. And this means that repeating a read or reading a piece of data that you've just written or changed should return the updated data within a second. The second option is called strongly consistent reads. And with strongly consistent, a read will always return a result that reflects all the writes that received a successful response prior to the read. So that really means that all successful writes will be reflected consistently across all 3 locations. DynamoDB is made up of tables and items. So when we say items, think of a row of data in the table. There's also attributes. So when you see attributes, think of a column of data in a table. It supports key value and document data structures. And when you see key value, the key is really the name of the data. So for example, user ID. And then the value is the data itself, so the user ID itself. And for document storage, documents can be written in JSON, HTML, or XML. So let's take a look at an example of a DynamoDB table. And this is one that I've already created, and it's just a simple table containing data about lectures. And each row in the table is an item in the database or a record, and each column in the table is an attribute of the item. So let's take a look at one of these items, and you can see that each item is made up of a series of key value pairs. So in this case, the key is category or the subject matter of the lecture, and then the value is DynamoDB. In the next key value pair, it's language, and the language is English, and so on and so on. And it's these key value pairs which appear in the database as attributes of the items in your table. And the next thing we're going to talk about is primary keys. So how do we actually query the data in the table? So DynamoDB stores and retrieves data based on a primary key. And it's this primary key that we use when we are querying the data. And there are 2 types of primary key. The first is a partition key. And the partition key is a unique attribute. So for example, a user ID, a product ID, an email address, etc. And the reason why it's called a partition key is because the value of the partition key is input into an internal hash function. And the output of this hash function actually determines the partition or the physical location where that data is going to be stored. So if you're using the partition key as your primary key, then no 2 items within your table can have the same partition key, because we can't store 2 items in the same physical location. Now the second type of primary key is called a composite key, and this is made up of a combination of a partition key and a sort key. So you would use this kind of composite key in a situation where the partition key was not necessarily unique within your table. So for example, think about a table which is storing data about forum posts, and you might be storing attributes such as a user ID, the name of the forum, the time they posted to the forum, and the message they posted in the forum. And in this example, the primary key could be a composite key which was made up of a partition key, which would be the user ID, then a sort key, which would be a timestamp of the post. And in this case, two items could have the same partition key because you could have the user posting multiple times in multiple forums or multiple times in the same forum. So in order to identify the record or the item uniquely, we need to use a combination of the user ID and the time they did their forum post. Now all items with the same partition key are stored together, and then they are sorted according to the value of the sort key. And once again, this allows you to store multiple items using the same partition key. So here's an example of a student table, and in the first record, and within DynamoDB, the record is called an item. So within that first item, we've got the unique ID of 1975. And in this case, this could be our partition key because we know it's a unique ID. Then we have a first name, surname, and a phone number. But think of another table where we might have a number of students and they might be taking multiple courses. So with our second example, we have our student called Riyad Ramanov. If he was to attend two different courses, then his unique user ID would not necessarily be a good primary key on its own, because he might appear in our database numerous times having attended multiple courses. So in this case, we need to use the composite key, and we need to use a partition key along with the sort key in order to give us that unique primary key. Access control to DynamoDB is all managed via Identity Access Management. And you can create an IAM user within your account who has specific permissions to access and create DynamoDB tables. You can also create an Identity Access Management role, which enables you to obtain temporary access keys that can then be used to access services like DynamoDB. And you can also use a special Identity Access Management condition to restrict user access to only their own records. So let's take a look at that in a little bit more detail. Imagine a mobile gaming application with millions of users, and the users need to access the high scores for each game that they are playing. However, access needs to be restricted to ensure they cannot view anyone else's data. So in the example here, we have a table with attributes such as user ID, game title, and top score. So a user is going to want to access their own record to view and update their own data, but they don't need to access anybody else's data. So how can we make sure the user gets access to the data they need, but doesn't see anyone else's data? Well, this can be done by adding a condition to an Identity Access Management policy. And this will allow the user to access only items where the partition key value matches their user ID. So if Camilla wants to check her high score when she logs into the application, she can only access her own scores in the database. She cannot view anyone else's data, she can't tamper with anyone else's scores, and she cannot delete anyone else's data. And here's an example of an Identity Access Management policy which does just that. So the first statement at the top is the statement identifier, and this just gives the policy a unique identifying name. Underneath that we have the effect, which is to allow. And then under action, this just defines the actions that the policy is going to allow. So it's going to allow get item, put item, and update item. Underneath that, it states the resource. So this is the unique Amazon resource name for your DynamoDB table. And then highlighted here is the condition clause. And it's this highlighted condition section which is really key to configuring this. And this is the section which configures it to allow users to access only the items where the partition key value matches their user ID. So it states that for all values, DynamoDB leading keys, or the partition key, that value needs to match the user ID that is requesting the data. So effectively, it allows users to access only the items where the partition key value matches their user ID. And then finally, the DynamoDB attributes section defines the attributes that the policy applies to. So let's take a look at some of our exam tips for DynamoDB. Well, firstly, it's a low latency NoSQL database. It consists of tables, items, and attributes. And when we think of items, think of rows in the database or database records. And when we think of attributes, just think of columns in the table. It supports both document and key value data models. And supported document formats are JSON, HTML, and XML. There are two types of primary key. Firstly, the partition key, and secondly, a composite key, which consists of a combination of a partition key and sort key. And the partition key could be something like a user ID or a product ID. And then the sort key is usually a range. It could be a timestamp or a date, etc. There are two consistency models within DynamoDB. Strongly consistent, which means that any writes that occurred before the read will be reflected in the read, and that will be consistent across all three locations. And also there is eventually consistent, and with eventually consistent, the performance can be better. However, it can take up to 1 second for new writes or updates to be reflected in your read. Access to DynamoDB is controlled by using identity access management policies, and you can implement fine-grained access control using identity access management condition parameters. And it's the DynamoDB leading keys parameter, which allows users to access only the items where the partition key matches their user ID. So that's the end of this lecture. It was just a quick overview of DynamoDB. And in the next lecture, we're going to go ahead and create our own DynamoDB tables and populate them with some data as well. So you'll have an opportunity to get your hands dirty with DynamoDB. So if you have any questions, please let me know. Otherwise, if you have time, please join me in the next lecture. Thank you. Hello, Cloud Gurus, and welcome to this lecture. And this lecture is going to be a lab all about DynamoDB. In this lab, we're going to create some DynamoDB tables using some PHP scripts, which we're going to run on an EC2 instance. And this instance is going to have a role assigned to it to enable it to interact with DynamoDB. So if you're ready to get started, please join me in the console. And the first thing that I'm going to do is create an identity access management role for our EC2 instance. So go ahead and find Identity Access Management under Security Identity Compliance. And we're going to go and click on Roles and Create Role. And it's going to be a service role for EC2. So click on EC2, then hit Next. And we're going to select a policy type. So click in the search box and we're going to just search for DynamoDB. And I'm going to select DynamoDB Full Access. Click on Next, and we need to give our role a name. So I'm just going to call it DynamoDB and click on Create Role. So that's our role down here created. And the next thing we need to do is go back to the dashboard, go back to Services and click on EC2 and click on Launch Instance and select the Linux AMI. And we're just going to stay with the T2 Micro. Click on Next. Most of these defaults we can just keep as the defaults, but there's a couple of things that we need to change. So first of all, we need to select our IAM role that we just created. So select DynamoDB. And then under Advanced Details, we've got a bash script or a bootstrap script to add in here, which is a script that's going to be run when the instance starts for the very first time. So that is in the resources section, but I've just got it copied, so I'm just going to paste it in now. And all this script does is it just, first of all, it tells us it's using the bash interpreter. It then does a yum update -y. It then installs Apache, PHP, and Git as well. It starts Apache, and it makes sure that Apache will continue to start on boot up. And then it changes directory to var www.html, and then it creates just a really simple test website. And then finally, it clones some code that we already have located in this GitHub location. So under github.com, acloudguru, DynamoDB. So once you have cut and paste that, and you'll just find this in the resources section of the course, you can just copy it and paste it in there. Then just hit on add storage. Next, add tags, and we're going to add a tag, and the tag we're going to add is name, and then we're going to just call this one DynamoDB EC2. Click on next, and you want to select a security group which has both HTTP and SSH. So I've got this one here that I created for a different lab, and it allows HTTP access via port 80 and also SSH access. So I'm going to select that one. However, if you don't have one, you can go ahead and create a new security group. You can just click that button here, but we don't need to do that. I'm just going to select the one that I already have here, and then click on Review and Launch. And then click on Launch, and select an existing key pair for your region. So I'm in the London region, and I already have a key pair for London, so I'm going to select that one. Again, if you don't have one, you can just click on Create New Key Pair, and it will create one for you that you can download. I'm just going to use the one that I already have, and then click on Launch Instances. And that might take a while, so I'm just going to pause the video now and come back when that has completed. And now here we are on the EC2 dashboard, and my instance has been launched. So I just select the instance, scroll down and find the public IP, copy that to clipboard, and now I'm going to go to my terminal window. And I'm going to type SSH -i and then the name of my key pair, EC2-user at, and then paste in the IP address of your EC2 instance and hit enter. And there we are inside the EC2 instance. So the first thing I'm going to do is sudo su, then cd var www html and hit ls. And we can see that a new directory has been created. The DynamoDB directory has been cloned from our Git repository. And there's also this test.php file, which is our web page. So then the next thing that we need to do is we need to install the SDK for PHP. And when we do that, there's a couple of commands that we need to run. First of all, we need to get Composer, and then we need to use Composer to install the latest version of the SDK. So I'm just going to show you a web page which has those commands in it. So this is the web page with the documentation for installing the AWS SDK for PHP. And the recommended way for installing the SDK is to use Composer, which is a tool that manages and installs the dependencies for installing PHP. So if we scroll down, there is a link to the command line installation for Composer for Linux. So we're installing this on our EC2 instance, so it's going to be the Linux installation. So I'm just going to open that in a new tab. And it gives us these 4 different commands that we need to run to download the Composer installer, verify it, then run the installer, and then finally remove it. And don't worry, I'm going to add a text file with all of the commands that you need to run in order to install Composer and install PHP. So that's going to be in the resources of the lecture. So I'm just going to start off by copying that first command. And the first thing I'm going to do is type sudo su, and then I'm going to paste that command into my terminal window. And a few students have reported issues with their T2 microserver running out of memory when going through these steps to install Composer and PHP. And unfortunately, we haven't been able to replicate the problem on our side, so we can't really explain why that might be happening. However, if you do experience memory issues when trying to run this set of commands, I've added a workaround that one of our students who experienced the issue has kindly provided, which just creates a swap file and should hopefully fix any memory issues that you are experiencing. Just go ahead and run these 3 commands, and they are in the resources section of the course, and then you should be able to continue. So now I'm going to come back to my web page and grab the second command and paste that. Copy our third command and paste. Then copy the fourth command and paste. Just going to clear the screen. Come back to our web page, and so we've downloaded and installed Composer. So the next thing that we need to do is run this command as well, and this is just going to install PHP. So I'll grab that and paste that into our window. It does just take a few seconds, but if it's successful, you should see a similar response to this. So now that has completed, let's just run ls, and we're going to change directory into the DynamoDB directory. And you can see there's two different files in here, two different PHP files. So there's one called create tables, and that script is going to create a bunch of tables in our DynamoDB. And the second one is called upload data, and that's going to upload some data into those tables. Now, the first thing that we need to do is we just need to make an update into this createtables.php to make sure that we're installing our tables in the correct region. So I'm just going to open that up now. And you'll want to come down where you see this section here where it specifies the region. And at the moment, mine is set to EU West 1. So what you need to do is replace that with whatever region you're working from. So whichever region you're running the EC2 instance in, that's the region that you want to specify here. So if I come back to my console, I'm in London. So that means I'm going to have to change my region because London is EU West 2. And actually you can see it down here as well, EU West 2A. So that's for the availability zone, but the region is EU West 2. So that means I need to go back and change that in my PHP file. So I'm going to come across here and replace that with 2 and then save. And then we are done with that file. And now we also need to make the same update in the upload data.php. And again, scroll down until you find region and come across and just replace that with your desired region. And save. And now we are done with those two files. So it's really important to make sure you change the region and you change it in both files, otherwise the lab will not work. And the next thing we're going to do is come back to our console window. And I'm going to go into DynamoDB now and just show you, this is the splash screen that you should see if you don't have any DynamoDB tables created already. So at the moment we've got nothing here, so I'm going to go back into my EC2 instance, go and find the public IP for that instance, select our instance and just copy that to clipboard. Then I'm going to open a new tab on my browser, paste the IP in our new browser tab, and then just hit /DynamoDB, and then the name of our createtables.php, and then hit enter. So this is just going to run that PHP script to create some tables within DynamoDB for us. And it just takes a few moments to complete. Okay, and we've just got the response now, just saying it's created a table for the product catalog, forum, thread, and reply. So it's created 4 tables for us. And now the next thing we need to do is we need to run that PHP script to upload data into our tables. So just come back to your browser window and we can just modify it. I'm going to delete the create tables and just replace that with upload data, and then just hit enter. So it's adding data into the product catalog, forum, and reply table now. So it says that's finished. So let's go back into the console and let's see what it's put in the tables for us. So come back to services and DynamoDB. Click on tables, and you can see it's created these 4 different tables for us. So let's take a look at the product catalog table, for example. Click on items, and we can see the upload data.php has populated our table with a load of different items. And we've got here a product ID, a price, category, title, type, brand, color, etc. And just notice that not all items have every single attribute. And that's one of the great things about DynamoDB, is that you don't have to have every single, it's very flexible. Not every item has to have the same type or number of attributes. And just notice here that you can either query, and you can query based on a product ID, for example, and we can enter a value here. So for example, if I enter a value, so if I enter 102 here, click on Start Search, it will search for an item in our table with the product catalog ID of 102. And then you can also run a scan as well, which will just show us everything in the table. If we click on Start Search for that, it will just show us absolutely everything in the table. And there's just one more thing that I want to show you, which is how to interact with our database using the command line. So I'm going to come back to my terminal window now. So I'm back in my terminal session on my EC2 instance, and I can actually use the AWS command line interface to query the database programmatically. And remember, we created the Identity Access Management role to give this instance DynamoDB full access, so it should be able to connect to our database and make queries. Now I already have the command in my clipboard, so I'm just going to paste it now. And this command simply uses the AWS CLI to talk to DynamoDB and to run a get item operation on the table name called product catalog. And the region is going to be EU West 2 because that's where my DynamoDB table is located. And the key is specified here, so that's the partition key. And the partition key is an ID, and the value is a numerical value, and the value is 205. So I'm searching the DynamoDB table for product with the product ID of 205. So I'm going to hit enter, and that has queried the table and it's brought up that product item. And this is all enabled by the Identity Access Management role, which has given us full access to DynamoDB. So if I go back to the console and go into Services and then back into Identity Access Management, and I'm going to go into that role, the DynamoDB role, and I'm going to delete that permission. And I'm actually going to delete the role. So now that role doesn't exist for our EC2 instance anymore. So let's go back to the instance and see if we can still run that database command. So I'm just going to hit up arrow and try and run the command again. There you go. So the security token included in the request is invalid and it's not letting us access our table. So just remember, if you want your EC2 instances to be able to access your DynamoDB tables, to be able to query them and insert items into them, they need to have that Identity Access Management service role to allow them access to the database. So that is DynamoDB, and we've just created some tables and populated them with some data so that you're able to now manipulate that data, run queries and searches, etc. And this will really help you as you progress through this section of the course, and it will really help you to get a little bit more familiar with DynamoDB and how it all works. So that is the end of this lecture. Hopefully that all worked for you. If you have any questions, please let me know. If not, please feel free to move on to the next lecture. Thank you. Hello Cloud Gurus, and welcome to this lecture. And this lecture is going to be all about DynamoDB indexes. So let's get started. So what is an index? Well, in SQL databases, an index is a data structure which allows you to perform really fast queries on specific columns within a table. And you can select the columns that you're interested in, that you want to include in that index, and then you run your searches against that index rather than on the entire data set. So it really makes your queries much more efficient. And in DynamoDB, there are two types of index supported to help speed up your DynamoDB queries. Now, DynamoDB, of course, it's not a SQL database, but it does still have this index feature. And in DynamoDB, there are two types of index that are supported, which will both help speed up your DynamoDB queries. So firstly, we have the local secondary index and also the global secondary index. So let's take a look at these in a little bit more detail. Now, a local secondary index is an index that can only be created when you are creating your table. So you cannot add, remove or modify it later. And it has the same partition key as your original table. but it does have a different sort key, and that's what gives you the different view on your data, because your data is going to be organized according to an alternative sort key. Any queries that are based on this sort key that you run against the local secondary index are then much faster than they would be if you were using the main table. So for example, in a customer table where you're storing all information about your customers, their email address, all the purchases they've made, all their contact details, etc. You might have a local secondary index which uses the main partition key of user ID and then uses a different sort key to your main table. So you might use a sort key like account creation date. Now for global secondary indexes, these are much more flexible. So you can create the global secondary index whenever you like. So you can either create it when you create your table or you can add it later on. And it allows you to choose a different partition key as well as a different sort key to your main table. So that gives you a completely different view of the data. And of course, it speeds up any queries that are relating to this alternative partition key and sort key. So for example, in our customer table, we might want to create a global secondary index using a different partition key of email address and then use a sort key of last login date. So what are our exam tips for the DynamoDB indexes? Well, firstly, indexes overall enable much faster queries, but only on very specific data columns. They give you a different view of your data based on an alternative partition key or an alternative partition key and an alternative sort key. And it's really important to understand the differences between these two types of index. So just remember, for the local secondary index, it must be created when you create your table, and it uses the same partition key but a different sort key. And for the global secondary index, you can create it at any time, either at table creation or afterwards, and it can have a different partition key as well as a different sort key. So that's the end of this lecture. If you have any questions, please let me know. If not, please feel free to move on to the next section. Thank you. Hello Cloud Gurus and welcome to this lecture. And this lecture is all about DynamoDB scan and query API calls. So there's two different ways of getting your information out of the database. We have scans and queries. And this lecture is just going to discuss the differences between the two of those. So let's get started. So what is a query? Well, a query operation finds items in your table based on the primary key attribute and also a distinct value to search for. For example, if you're looking for an item where the user ID is equal to 212, you're going to query the DynamoDB table based on the primary key of user ID, and the value will be 212. And that will select all the attributes for that item. So for example, if you were storing the first name, surname, email, etc., all those attributes would come up in that query. And you can use an optional sort key name and value to refine the results if you have multiple results. For example, if your sort key is a timestamp, you can refine the query to select only the items with a timestamp of the last 7 days. So for example, you might want to query the last time a user logged into a forum, the last time they posted in a forum, that kind of thing. Now by default, a query returns all the attributes for the items, but you can use the projection expression parameter if you want the query to only return specific attributes that you're looking for. For example, if you only wanted to see the user ID and email address, rather than all the attributes for that item in the table. Results are always sorted by the sort key. If they're numeric, they're sorted in numeric order, and that by default is in ascending order, so 1, 2, 3, 4. And if they're ASCII characters, they are also sorted by default in ascending order. And you can reverse the order by setting the scan index forward parameter to false. This only applies to queries, and unfortunately they've called it scan index forward, but it does only apply to queries. So just remember that if you see any questions relating to scan index forward parameter, it's relating to queries and not scan, and it's to reverse the order of the results from your query. By default, all queries are eventually consistent, but you can set them to be strongly consistent, but you need to explicitly set the query to be strongly consistent. So moving on to scans. What is a scan? Well, a scan operation examines every single item in the table, and by default it returns all the data attributes. Once again, you can use the projection expression parameter to refine your scan results to return only the attributes you're looking for. And you can also filter the results of the scan once it's been run. But it's a lot easier to understand the difference between scans and queries if I actually show you in the console. So I'm going to move to the console now so I can show you exactly what I mean. So here I am in the console and I'm in the DynamoDB section, and I'm going to go to my tables. And these are the tables that we set up. If you did the previous lab already, then you'll be able to try this yourself on your own tables. So first of all, I'm going to go to the product catalog table and click on items. And these are all the items in my product catalog table. So first of all, I'm going to run a query. I'm going to select query here, and I can query on the partition key. And for this table, the partition key is the ID, so it's the product ID, and it's this attribute here in this column. And I can query based on one of these attribute IDs. I can query based on the partition key, it's a numerical value, and I can enter a value here that I want to search for. So I'm going to search for 202 and click on Start Search, and it's found my item with the product ID 202. So now let's compare that to a scan operation. So if I select Scan instead and click on Start Search, it gives me the entire table. And if I want to refine these results, I need to add a filter. So I'm going to add a filter here, and I'm going to filter on price. So I can filter on any of these attributes here. So I'm going to filter on price, and it's the numerical value, so I'll change that to number. And you've got a load of choices, so I can search for items of a specific price or greater than, less than. So I'm going to search for items greater than 100. Click on search, and it will apply that filter. But the thing to remember with the scan is it's not searching the database. It's first dumping the data, the entire table, and then it's applying a filter on top of that to show us only the results that we're looking for. So what should we use, a query or a scan? Well, a query is much more efficient than a scan because the scan dumps the entire table, then filters out the unwanted values to provide the desired result. And this adds the extra step of removing the data that you don't want. And as the table grows, the scan operation takes longer and longer. And a scan operation on a large table can actually use up the provision throughput for a large table in just one single operation. And there are some ways to improve performance. So you can reduce the impact of a query or scan by setting a smaller page size, which uses fewer read operations. For example, you can set the page size to return 40 items, and this means that you'll end up with a larger number of small operations, which will allow other requests to succeed without throttling the database. But in general, you should try and avoid using scan operations if you can. Instead, design your tables in a way that you can use the query, get, or batch get item APIs. And the second option is that you can use parallel scans. So by default, a scan operation processes data sequentially, and it returns it in 1 megabyte increments before moving on to retrieve the next 1 megabyte of data. And it can only scan one partition at a time. However, you can configure DynamoDB to use parallel scans instead by logically dividing a table or index into segments and then scanning each segment in parallel. And this can work really well if your database is not already really busy. However, it's best to avoid parallel scans if your table or index is already incurring heavy read-write activity from other applications, because the parallel scans could well impact the other applications. So what are our scan and query exam tips? Well, just remember a query operation finds items in the table using only the primary key attribute. And you need to provide a distinct value to search for. So remember when I searched in the table for a product ID of 202 and then the query operation found that product for me. A scan operation examines every item in the table. By default, it returns all the data attributes, but you can use the projection expression parameter to refine the results. And you can also use the filter like I did earlier. So I used that filter. So I used the filter to refine the results to products which had a price greater than 100. Query results are always sorted by the sort key if there is one. They're sorted by default in ascending order, and you can use the scan index forward parameter to false to reverse the order for queries only. And remember, a query operation is generally more efficient than a scan. Reduce the impact of your query or scan by setting a smaller page size which uses fewer read operations. And for scans, you can also try to isolate the scan operations to specific tables. Alternatively, try out parallel scans rather than the default sequential scan. However, in general, avoid using scan operations if you can, and design your tables in a way that can use query, get, or batch get item APIs. So that is the end of this lecture. If you have any questions, please let me know. If not, please feel free to move on to the next lecture. Thank you. Hello Cloud Gurus and welcome to this lecture. And this lecture is all about DynamoDB provisioned throughput. And provisioned throughput is the mechanism that we use to define the capacity and performance requirements in DynamoDB. So let's get started. So DynamoDB provisioned throughput is measured in capacity units. And when you create your table, assuming you're not using auto-scaling, you need to specify your requirements in terms of read capacity units and write capacity units. And one write capacity unit is equal to one kilobyte write per second. And one read capacity unit is equal to one strongly consistent read of 4 kilobytes per second, or two eventually consistent reads of 4 kilobytes per second. And eventually consistent reads are the default. So let's have a look at an example configuration. So think of a table with 5 read capacity units and 5 write capacity units configured. And this configuration will be able to perform 5 4 kilobyte strongly consistent reads, which equals 20 kilobytes per second. It will be able to perform twice as many eventually consistent reads per second, so that would be 40 kilobytes per second. And it will be able to perform 5 1 kilobyte writes per second, which equals 5 kilobytes per second. Now, if your application reads or writes larger items, it's going to consume more capacity units and it will cost you more as well, because the price goes up the more read and write capacity units you are provisioning. So let's have a look at how we calculate the requirements, how we work out how many read or write capacity units you're going to need for your application. So imagine you have an application and it needs to read 80 items or table rows per second. And each item is 3 kilobytes in size. And you need strongly consistent reads. First of all, you need to calculate how many read capacity units are needed for each read. So the way we do that is we take the size of each item and divide it by 4 kilobytes. So 3 divided by 4 is 0.75. Round that up to the nearest whole number. So each read is going to need 1 read capacity unit per read operation. And then we simply multiply that by the number of reads per second. So in this case, 80 reads per second. So that's going to be 80 read capacity units required for strongly consistent reads. But what about eventually consistent reads? Well, you do exactly the same calculation. However, as this is for eventually consistent reads, and you get 2 4 kilobyte reads per second with eventually consistent, which is double the throughput of strongly consistent. Just take your calculation for the strongly consistent reads and you can just divide it by 2. So we take the size of each item divided by 4 kilobytes. 3 divided by 4 is 0.75. Rounded up to the nearest whole number is 1. then multiply that by the number of reads per second is 80, divide it by 2 because you get double the throughput for eventually consistent. So that means you only need 40 read capacity units for eventually consistent reads for this example. But what about write capacity units? Well, just imagine you want to write 100 items per second into your table, and each item is 512 bytes in size. So firstly, you would calculate how many capacity units are needed for each write. So the size of each item divided by 1 kilobyte for write capacity units. So that's 512 bytes divided by 1 kilobyte equals 0.5. Round that up to the nearest whole number. So each write will need 1 write capacity unit per write operation. And then multiply that by the number of writes per second. So that's 100 write capacity units required in this example. So let's have a look at some of our exam tips. So it's really important to understand read and write capacity units. And it's important to know how to do those calculations as well, because if you do get asked in the exam, it will be really easy marks if you know how to do the calculation. So just remember, provision throughput is measured in capacity units. One write capacity unit is one kilobyte write per second. One read capacity unit is 1 4 kilobyte strongly consistent read, or 2 4 kilobyte eventually consistent reads per second. So that is the end of this lecture. As I said, it's really important to understand how to do those calculations. So it's definitely worth doing our quizzes and doing our tests and making sure that you fully understand how to do those calculations. But if you have any questions, please let me know. If not, please feel free to move on to the next lecture. Thank you. Hello Cloud Gurus and welcome to this lecture. And this lecture is all about the DynamoDB on-demand capacity pricing option. So let's get started. At reInvent 2018, they introduced a new pricing option for DynamoDB. So in addition to the provisioned throughput model, which we've already talked about, where you specify your read and write capacity units, they have also introduced this on-demand capacity pricing model as well. So with on-demand capacity, charges will apply for reading, writing and storing your data. But the difference is with on-demand, you don't need to specify your capacity requirements. So you don't need to specify your read and write capacity unit requirements. DynamoDB will instantly scale up and down based on the activity of your application. So based on the number of reads and writes that your application is making to the database. And this is going to be really great for unpredictable workloads. So for example, if you don't know the capacity requirements of your application, if your application traffic is difficult to predict, or your workload has large spikes which are short-lived, or if it's a brand new application where the workload is not really very well understood. And it's also really good if you only want to pay for what you use when you use it. So a pay per request model. And this is going to be great for serverless stacks, which have that pay per use pricing model. So I know what you're thinking. Which pricing model should I use? Well, for workloads where you have unpredictable application traffic, you don't know what the workload's going to look like. If you want a pay per use model, so for example, if the rest of your stack is serverless and you're paying per use for everything else, or if you have spiky and short-lived peaks, then under those circumstances, you should go for the on-demand capacity. However, if you have predictable application traffic, you can easily forecast your read and write capacity requirements. Or if your application traffic is consistent or it's increasing gradually, then under those circumstances, it's more cost-effective to use the provisioned capacity. And you can actually change your DynamoDB table from provisioned capacity to on-demand once per day. So they actually let you switch between the two pricing models. Now this new on-demand option, it was only introduced right at the end of November. So it was announced at reInvent 2018, and they do wait at least 6 months before introducing a new feature into the exams. And in practice, it can be much longer than 6 months before they actually update the exams. So right now, we don't think this is going to feature in the exam in any detail, but it's just good to be aware of when you are designing your DynamoDB tables. So that's the end of this lecture. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Hello Cloud Gurus and welcome to this lecture. And this lecture is called DynamoDB Accelerator and it's also known as DAX. So let's get started. So what is DAX? Well, DynamoDB Accelerator or DAX is a fully managed, clustered, in-memory cache for DynamoDB. And it really gives you a massive performance improvement for your DynamoDB tables, but only for read performance. And they claim that it can deliver up to a 10 times read performance. That really is significant. So it gives you microsecond performance and for millions of requests per second. So it's ideal for read heavy and also bursty read workloads. For example, auction applications, gaming applications, and retail sites specifically during Black Friday promotions or at Christmas time or any time when they have a special promotion on. So for example, just think of a retail website and they're running a big promotion. They've got all their product catalog data in DynamoDB. Of course, while those promotions are on and while there's really good bargains to be had, a lot of people are going to be wanting to look at their website, to look at all the information about their products and decide which products they're going to buy. So in that situation, DynamoDB would get really hit really hard. There would be many, many read operations. And that's a really good example of when you could use DAX to improve the read performance for all of those different calls. So how does it work? Well, DAX is a write-through caching service. And this means that data is written to the cache as well as the backend store at the same time. So that means that any time the DynamoDB table gets updated, you add a new item or you modify an item, as well as writing that change into DynamoDB, it also gets written to DAX as well. It also allows you to point your API calls at the DAX cluster. So instead of having your application query DynamoDB, it will try and query the DAX cluster first. And if the item you're looking for is in the cache, and that's a cache hit, DAX will then return the result to the application. However, if the item is not available and that's a cache miss, then DAX performs an eventually consistent get item operation against DynamoDB. So it gets the item out of DynamoDB, it writes it into its cache, and it also hands it back to the application. So retrieval of data from DAX reduces the read load on your DynamoDB tables. And in some cases, you may even be able to reduce the provisioned read capacity on your tables. So that means you can save some money on your DynamoDB bill. But what is it not suitable for? Well, it caters for eventually consistent reads only. So it's not going to be suitable for applications that require strongly consistent reads. So if your application really requires strongly consistent reads, DAX is not going to be a benefit in that situation. It's also not really suitable for write-intensive applications. So you're not going to get a benefit from using DAX because it only helps with read operations. Also, applications that don't perform that many read operations are not really going to see a benefit from configuring DAX. And the same goes for applications that don't require microsecond response times. There's no point in configuring it if you don't need that low latency. So what are our exam tips? Well, just remember DAX provides in-memory caching for your DynamoDB tables. It improves the response times for eventually consistent reads only. You point your API calls at the DAX cluster instead of your table. If the item you're querying is on the cache, DAX will return it. Otherwise, it's going to perform an eventually consistent get item operation to your DynamoDB table. And it is not suitable for write-intensive applications or applications that require strongly consistent reads. So that's the end of this lecture. If you have any questions, please let me know. If not, please feel free to move on to the next lecture. Thank you. Hello Cloud Gurus and welcome to this lecture. and this lecture is all about Elasticache. And Elasticache is in-memory caching, and it can sit in front of any kind of RDS database, and also it can be used in front of DynamoDB as well. So let's get started. So what is Elasticache? Well, it's in-memory cache in the cloud, and it's used to improve performance of web applications, allowing you to retrieve information from fast in-memory cache rather than slower disk-based databases. It sits between your application and the database. For example, an application frequently requesting product-specific information for your best-selling products. So for the best-selling products, the application is frequently requesting the same information. And by caching that, it just makes the subsequent request for that information much faster, because they don't have to go to the database and retrieve it from the disk. When we get data out of the cache, it's much faster. And it also takes the load off your databases. And it's really good if your database is particularly read heavy, and also if the data is not changing very frequently. So some of the benefits are that it improves performance for the read-heavy workloads, for example, social networking, gaming, media sharing, and Q&A portals. Frequently accessed data is stored in memory for low latency access, which improves the overall performance of your application. And it's also really good for compute-heavy workloads, so for example, recommendation engines, because it can be used to store results of your I/O-intensive database queries, and also the output of compute-intensive calculations. And there are two types of Elasticache. There's Memcached and Redis. And Memcached is really widely adopted. It's multi-threaded as well, so it's really good if your applications are multi-threaded. However, there's no multi-AZ capability, so it's not clustered, it's only standalone. If AWS loses that Elasticache service, you're going to lose everything that's stored in your cache. And there's also Redis, which is it's open source, and it's an in-memory key value store. So when we say key value, the key is normally the name, and the value is the actual data stored. It supports more complex data structures like sorted sets and lists, and crucially, it also supports master-slave replication and multi-AZ for cross-AZ redundancy. So this is a better choice if it's really important not to lose the data that's been cached. If Elasticache went down, if the Elasticache node went down, and you lose the data, your application loses the data that's stored in the cache. If that's going to be a problem, then Redis would be preferable because you've got the multi-AZ cross-site redundancy. Now there are two caching strategies available: lazy loading and write-through. Now lazy loading, it loads the data into the cache only when necessary. So when a request is made, if the data is in the cache, Elasticache will return the data to the application. But if it's not in the cache or it has expired, Elasticache then returns a null. And then your application fetches the data from the database and it writes the data received into the cache so that it's going to be available next time. Now the advantages of this are that only the requested data is cached, so that means it avoids filling up the cache with useless data that never gets requested. It also means that a node failure is not going to be fatal. So if your Elasticache node fails and you bring up a new one, it just means that new node is going to have an empty cache and it's going to have a lot of cache misses initially. Some of the disadvantages of lazy loading are that there is a cache miss penalty. So if you want to retrieve some data from Elasticache and it's not in the cache, you have a cache miss. So you've made the initial request. You then have to query to the database anyway. And then finally, you need to write the data into the cache for next time. So there is that additional overhead of the initial request, query to database, and writing the data to the cache. Additionally, with lazy loading, the data can become stale. So if data is only updated when there's a cache miss, it can therefore become out of date. And it doesn't automatically update if data in the database changes. So how do we deal with this stale data? Well, within Elasticache, we can add a time to live or a TTL to our data. And this specifies the number of seconds until the key or the data expires to avoid keeping stale data in the cache. Lazy loading will then treat an expired key as a cache miss, and this will cause the application to go and retrieve the data from the database and then subsequently write that data into the cache with a new TTL. And depending on how frequently your data changes, this doesn't eliminate stale data, but it does help to avoid it. Now, another caching strategy is called write-through caching. And this adds or updates data to the cache whenever data is written to the database. And the advantage of this is that the data in the cache is never stale. However, it does involve a write penalty because every write involves a write to the cache as well as a write to the database. However, users are generally more tolerant of additional latency when updating data than they are of when retrieving it. So maybe we could say that write penalty is not such a big disadvantage. If a node fails and a new one is spun up, data is missing until added or updated in the database. Although we can mitigate that by implementing lazy loading as well, in conjunction with write-through. However, one of the main disadvantages of the write-through strategy is that you end up with wasted resources if most of your data is never read. So if you have a database where a few records or a few items in your database are very frequently accessed, and then most of the vast majority of the data in your database is hardly ever read, it wouldn't make sense to use the write-through caching strategy. And you might be wondering, what is the difference between DAX and Elasticache? Because they both provide in-memory caching and both are supported for DynamoDB. But just remember that DAX is the one that is optimized only for use with DynamoDB. It was specifically developed just for DynamoDB, and DAX only supports the write-through caching strategy. It doesn't let you use any other caching strategy like lazy loading, for example. So if your application is using DynamoDB and it needs to use an in-memory cache and you need to use lazy loading, you can't use DAX, and in that instance you would select Elasticache. But generally speaking, for DynamoDB, DAX is the one to use and Elasticache is the one to use for RDS. So what are the Elasticache exam tips? Well, just remember it's an in-memory cache. It sits between your application and database. It uses two different caching strategies. We have lazy loading and write-through. Lazy loading only caches the data when it's requested, and an Elasticache node failure is not fatal. You just get lots of cache misses with lazy loading. There is a cache miss penalty, so your initial request, query database, and writing to the cache with lazy loading. And you can avoid stale data by implementing a time to live on your data. The write-through strategy writes data into the cache whenever there's a change to the database. The data is never stale. However, there's a write penalty because each write involves a write to the cache. And an Elasticache node failure means that the data is going to be missing until added or updated in the database. And you've got wasted resources, unfortunately, if most of your data is never used. So that is the end of this lecture. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Hello Cloud Gurus and welcome to this lecture. And this lecture is just going to be a really quick lecture introducing DynamoDB transactions. So what are DynamoDB transactions? Well, this was something that was introduced at reInvent 2018, so in late November 2018. And DynamoDB transactions are to support mission-critical applications which need an all-or-nothing approach to their database transactions. And you may have heard the term ACID before in relation to database transactions. And ACID is just an acronym. It's used to describe the ideal properties of a database transaction. And those properties are that each transaction should be atomic, so that guarantees that the transaction is treated as a single unit. So basically it's all or nothing and it cannot be partially completed. The transaction must also be consistent, and that just means that it must be a valid transaction. It must leave the database in a valid state, and that just simply prevents any database corruption or data integrity issues. Transactions must be isolated, and that just means that there's no dependency between different transactions. They could either be completed in parallel or sequentially. The effect of the transaction is going to be the same. And finally, the transactions must be durable. And this just means that when a transaction has been committed, it's going to remain committed even after a system failure or a power loss. So once it has been committed, that means it's going to be written to disk rather than being held in memory. So the main idea is that transactions which possess these qualities can be treated as a single operation on the data, and the durability of the operation is guaranteed in the event of a system or power failure. And this is really great for mission critical systems. So for example, if you think about a financial transaction, if you are transferring money between one account and another, that kind of transaction, it might involve multiple steps. So for example, checking there are sufficient funds in the sending account, then debiting the account, and then finally crediting the receiving account, and doing that all as one single transaction. And for that kind of transaction, you really want it as an all or nothing transaction. You wouldn't want that kind of transaction to be partially completed. And of course, you want it to be durable across system failures. So if the system reboots or the application restarts, you want that transaction to still be in the system after a reboot or a restart. So let's see how that could really work in practice in DynamoDB. Imagine you are developing a game where each player can purchase items using virtual coins. You might have two different tables. So for example, we've got a player's table here, including the player ID, any inventory they have, so any items they've already purchased, and how many coins they have. We then have an items table with all the items available to purchase, a price, whether they are available, true or false, and who they are owned by. So you could use DynamoDB transactions to run a single atomic transaction. So if my player, Faye, wants to purchase, for example, one of the items in the table, you can actually create a DynamoDB transaction which will check that an item is available. If I wanted to purchase the berry, I could have DynamoDB check whether the item is available. So yes, it is. The availability is true. It can then check whether I have enough coins to purchase the item. And then if those two conditions are satisfied, the item can then be marked as owned by me, and then it can appear in my inventory as well. And that can all be accomplished using a single DynamoDB transaction. So you can see that this is a really powerful new feature which allows you to implement complex business logic into a single atomic transaction. And as I said, this was only announced at reInvent 2018, so the end of November 2018. And we don't expect it's going to appear in the exam for at least another 6 months or so after the announcement. It's just really good to be aware of when you're designing your own DynamoDB tables, but we don't expect it to appear in the exam straight away. So that is the end of this lecture. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Hello Cloud Gurus, and welcome to this lecture. And this lecture is going to introduce DynamoDB TTL. It's also known as DynamoDB Time to Live. And this is a topic that has been coming up in the exams recently based on student feedback. So this lecture is going to just cover off TTL so you know exactly what it is for the exam. So let's get started. So what is DynamoDB TTL? Well, TTL, or time to live, it's an attribute which defines an expiry time for your data. So you define an expiry time, and expired items are automatically marked for deletion. And once an item has been marked for deletion, that means it's going to be deleted within the next 48 hours. And this is really good for removing any irrelevant or old data, so data that's no longer useful to your application. So think session data, event logs, any temporary data, so any data that's no longer useful to your application after a certain period of time. And this is going to really help to reduce costs for storing data in DynamoDB, because it automatically removes data which you no longer need. So the data is no longer relevant, so it just does that housekeeping for you and automatically deletes the data. So let's take a look at how that actually works within DynamoDB. And I've got an example session data table here. So we're just storing the user ID, session creation time, and the time to live, and then finally the session data itself. And the first thing you're probably going to notice is that time to live is expressed in a pretty strange format. It's expressed in the epoch time format. And if you haven't heard of that before, it's also known as Unix time, and it's also known as POSIX time as well. And epoch time or Unix time or POSIX time, that is a numerical value, and it represents the number of seconds which have elapsed since 12 a.m. on January the 1st, 1970. So even before I was born, in fact, a long time before I was born, and probably a long time before a lot of you were born as well. So that is just the way that Unix systems see time, and that's how they express time as a numerical value. Now, in this example, I'm setting the expiration time on our item, and I'm setting it for 2 hours after the session originally began. And don't worry, you can just use one of these really useful translation websites. And I've got one to show you. I'm just going to head over there now. So this is the website I normally use. It's just called Epoch Converter, but I'm sure you can find one just by Googling or use your favorite one. And you can just go in and set the day, set the hour to what you want to, and then just translate it into an epoch timestamp. So that's the kind of thing you can use if you are defining your TTL. And it's this epoch time number which actually allows DynamoDB to easily compare your time to live to the current time right now. And in this example, the expiration of this item is set for 2 hours after the session originally began. And so when the current time is greater than the TTL, the item is going to be expired, and it gets marked for deletion, and then within the next 48 hours it's actually going to be deleted. So that's actually quite a long window between being marked for deletion and actually getting deleted. So in order to cater for that, you can actually filter out any expired items from your queries and scans. But let's take a look at how this actually works within the DynamoDB console. But first of all, we're going to need to create our own DynamoDB table. And I prepared a couple of commands that we're going to run. And before we do that, you just need to make sure, of course, that your AWS CLI is configured with credentials of a user who has the correct permissions to go ahead and create DynamoDB tables. So the first thing I'm going to do is I'm going to type AWS IAM get-user. And this is just going to tell us which user we have used when we configured the AWS CLI. So when we ran AWS configure, this is the user credentials that I used originally. So I'm just going to come back to my console and just double check the credentials of that particular user. So I'm going to go to services and then IAM. I'm going to find my user. So it was Faye. And I'm just going to check that that user has the correct permissions. So my user's actually got administrator access, but if you don't have any DynamoDB access, if you didn't have administrator access on that account, then you can just go ahead and add permissions, go to attach existing policies, and then just search for DynamoDB, and you can add DynamoDB full access to that user, and that will make sure that you have access to use DynamoDB. So once you're happy with that, I'm going to come back to the console, and I've actually prepared a couple of commands that we're going to run. So we're going to run one command to firstly create our new table, and then we're going to run another command to populate the table. So I'll show you those commands before we run them. And these are going to be included in a text file in the resources of the course, so you'll be able to just copy and paste these. So the first command is this one, and this actually creates our session data table. So first of all, it runs the create table command. It provides a table name of session data, and then it defines our primary key, which it calls it the hash key, and that's just an alternative name that they use for the primary key or the partition key. So we're going to define our hash key as being the user ID, and the attribute type is going to be of type number. And then finally, the last thing we stipulate in this command is the provision throughput, read capacity units of 5 and write capacity units of 5. So you just copy that command, and don't worry, you don't need to understand all of the different options. You don't need to understand the DynamoDB commands, the CLI commands for the exam. They're not going to test you on that. It's just the quickest way to create the table for the purposes of this lecture. So then just come back to the console, and I'm just going to paste that into my console, hit enter, and hopefully if that's been successful, you should see this kind of output summarizing what we've done in DynamoDB. And then the next command we're going to run is going to perform a batch write item, and this is going to write a number of items into our new table, and it takes as input this request items file, which is going to be a file called items.json, and you're going to need to download this from the resources section of the course. So if I show you items.json, it's simply a JSON file which is going to create these items in our session data table. So the first thing it does is it stipulates the name of the table, which is session data, and then it defines a number of put requests and the items that we're actually going to put into that table. So we've got our user ID, it's going to be a number, this number here is the actual user ID, then we've got the session creation time, expiration time, and a session ID as well. So it just creates 3 different items which it's going to put into the table. So if we come back to our command, I'm just going to copy and paste that. Okay, and if that's successful, we can come back to our console and we can just check whether that table got created successfully. So come to Services, DynamoDB, and make sure that you are in the correct region where you have run AWS configure. So on my system, I'm in US East 1. So I just need to make sure that I am looking at the US East 1 region, which I am. And then if we go to tables, and there is our session data table. So if you click on the table, click on items, and that should be the items that we have just populated. So if that has run successfully for you, you should have 3 items in your table with a user ID, creation time, expiry time, and a session ID. And I've just set this expiry time to midnight tonight. And today is the 6th of December, so I have set the expiration time for these items to be the 6th of December at midnight. So you might want to update this, set it to midnight tonight for whatever day it is when you are watching this lecture. So if you want to do that, once again, just go back to the epoch converter and you can create an epoch timestamp using whatever date you want to. So let's say February the 2nd, 2019. You can just configure the date that you want and then grab the epoch timestamp, and you can set it to whatever hour, minute and second you want as well, and set whatever the local time is for wherever you are located. So feel free to go in and update that expiration time if you want to follow along on this lecture. So once you're happy with all of that, we can actually go ahead and start playing around with the time to live for these items. So if you head to Actions, click on Manage TTL, and the first thing it's going to ask you to do is define which attribute you are basing the time to live on. And we are going to be using this expiration time as our TTL attribute. So you need to just type in the name of your attribute. And DynamoDB actually allows you to preview TTL before you actually go ahead and apply it. So we can, first of all, we can run a preview based on previewing items expiring by 3:30 on today's date. So I'm just going to hit Run Preview. And that's what we should expect to see. We shouldn't expect it to see any items expiring by 3:30 today, because all of these items are set to expire at midnight tonight. So let's just change that to December the 7th and midnight. And we can run the preview again. And there we are. It should catch all 3 of those items because they are due to expire at midnight. So if you want to go ahead and configure time to live for all of these items, you can hit Continue. And then if we go back to Overview, you should see under the table details, the time to live attribute. It's configured as the attribute that we defined earlier, so the expiration time. So that is DynamoDB TTL. The main thing to remember is that you can use it to define expiration times for your data. It will mark your data for expiration As soon as the current time is greater than the TTL, the item will then be expired, marked for deletion, and then deleted within 48 hours. And just remember, you can filter out the expired items from your queries and scans so that you don't see them when you query and scan your data. So that is everything you need to know about TTL. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Hello Cloud Gurus, and welcome to this lecture. And this lecture is all about DynamoDB streams. And we've had some student feedback recently that DynamoDB streams are coming up in the exam. So this lecture is just to tell you everything that you need to know about DynamoDB streams. So let's get started. So what are DynamoDB streams? Well, a DynamoDB stream is a time-ordered sequence or stream, and it records any modifications made to the items in your DynamoDB table. So anytime there's an insert, update or delete operation, it's going to record that in your DynamoDB stream. So it records all of these actions as a log, and the logs are encrypted at rest and they're stored for 24 hours only. So that means after 24 hours it's going to start deleting those entries. And typically DynamoDB streams, they can be used for auditing or archiving of transactions, replaying any transactions to a different table, but they're mainly used to trigger events based on a particular change within the DynamoDB table. So they're really, really good for serverless architectures. You can use a DynamoDB stream to trigger a Lambda function, for example, or to trigger your application to do something based on a change in the DynamoDB table. And the streams are accessed using their own dedicated endpoint. So there's one endpoint to access the DynamoDB table itself, and then there's a second separate endpoint for the DynamoDB stream. And by default, the minimum amount of data you can record is the primary key of the item that is being modified, updated, or deleted. But you can also store before and after images. So you can capture the state of the item before the change and the state of the item after the change as well. So let's take a look at a simple architecture for DynamoDB streams. So we've got our application at the top, and it uses the DynamoDB API to speak to its DynamoDB tables. So it's got one endpoint for the DynamoDB table, and then there's a completely different DynamoDB Streams API and a different endpoint for its DynamoDB stream as well. And just remember, the event data is only held for 24 hours before they start deleting it. Now, the events are recorded in near real time. So once again, that makes it really, really good for serverless architectures and to build applications which respond to changes in your DynamoDB table. Applications can take actions based on the contents of your stream, so based on what's going on within your DynamoDB table. It makes a really good event source for Lambda. So Lambda will poll the DynamoDB stream and then can execute code, launch functions based on events happening within your DynamoDB stream. So let's take a look at an example scenario using DynamoDB streams to trigger a workflow. And in this example, we have an invoicing and payments system, which is recording invoice data into a DynamoDB table. And each time a new invoice entry is made into the DynamoDB table, there's a Lambda function which reads the DynamoDB stream to check for new transactions. And then when it sees a new event, sends a notification using SNS, which in turn creates a message in an SQS queue. And you can then have your payments application polling that SQS queue, processing the message, and maybe it performs various tasks like generating a payment request, adding an item to a customer's bill, etc. So you can see this is a really powerful way to generate triggers to Lambda, to trigger your application, to take actions based on the changing contents of your DynamoDB table. So let's take a look at the exam tips for DynamoDB streams. Well, just remember, it's a time-ordered sequence of item-level modifications in your DynamoDB tables. So every time an item gets changed in your DynamoDB table, it's going to record that in the DynamoDB stream. The data is only stored for 24 hours, and after that, it's going to start getting deleted. And it's a really good event source for Lambda, allowing you to create applications which can take actions based on events happening within your DynamoDB table. So that's the end of this lecture. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Hello Cloud Gurus and welcome to this lecture. And this lecture is all about the provisioned throughput exceeded exception and exponential backoff. So let's get started. Now, the provisioned throughput exceeded exception is one that you might see on your DynamoDB table if your request rate is too high for the read and write capacity provisioned on the DynamoDB table. So for example, if your application is making too many requests into the DynamoDB table, so too many read and write requests for the table to handle based on its read and write capacity provision. Now, if you're using the AWS SDK, it's going to automatically retry the requests until they are successful. However, if you're not using the SDK, you're going to have to configure your application to do one or both of the following things. So firstly, you can reduce the request frequency. So reduce the number of concurrent requests that are being sent to the DynamoDB table, reduce the frequency of the requests that are being sent to the table. And the second thing you can do is to implement exponential backoff. Now, what is exponential backoff? Well, many components in a network or in a given system can generate errors due to being overloaded by too many requests, all coming in at the same time. And that could be any component that you can think of, so maybe network switches, DNS servers, load balancers, etc. Pretty much any part of the network can experience overloading due to too many concurrent requests. And the usual way of dealing with this is to implement retries from the client application. So for example, for the client to keep on trying to send a request until it gets a response. And all of the AWS SDKs, they all implement automatic retries, which simply send the request again until it is successful. But in addition to these simple retries, all AWS SDKs also use exponential backoff. And with exponential backoff, this means that the requester will implement progressively longer waits between consecutive retries of a failed request. After the first failed request, it might wait, for example, 50 milliseconds before trying again. And then if that retry fails, it then might wait 100 milliseconds until trying again. And then if that retry fails, it might wait 200 milliseconds before trying again. So it will continue like that until the request is successful. And this gives significantly improved flow control in the hope that at some point the traffic is going to start flowing freely again and requests will start to be fulfilled again. But if after about 1 minute this doesn't work, it might be instead that your request size is actually exceeding the throughput for your read and write capacity on the DynamoDB table. So in this case, it may be worth investigating your provisioned throughput. And if your workload is mainly GET requests, you might be able to improve performance using either DynamoDB Accelerator or DAX, or using Elasticache. However, if it's mainly write requests that are causing the issue, then maybe take a look at increasing your write capacity for the DynamoDB table. So what are our exam tips? Well, if you see the provisioned throughput exceeded error, this means that the number of requests into your DynamoDB table is too high. Exponential backoff can be used to improve the flow control by retrying the requests using progressively longer waits. However, if your wait is getting up to around 1 minute, it's definitely worth checking your read and write capacity unit settings and seeing if they need to be adjusted. And just remember that exponential backoff, it doesn't only apply to DynamoDB. It's actually a feature of every single AWS SDK, and it applies to many services within AWS, for example, S3 buckets, if you're using CloudFormation heavily, and SES, etc. And if you're not using the AWS SDK, then you're going to need to handle this yourself in your application settings or in your application code. So the way to do that is just to reduce the frequency of your requests and implement exponential backoff yourself. So that is the end of this lecture. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Hello Cloud Gurus and welcome to this lecture. And this lecture is the DynamoDB summary. So it's everything that we've learned in the DynamoDB section. So let's get started. So DynamoDB is a low latency NoSQL database consisting of tables, items, and attributes. It supports both document and key value data models, and the supported document formats are JSON, HTML, and XML. And there's two types of primary key. Firstly, the partition key, so that could be something like a user ID, and a combination of a partition key and a sort key, which is called a composite key. That might consist of a user ID plus also the date the account was created. There are two consistency models. So we have strongly consistent and eventually consistent. And of course, if you need the most up-to-date data for your application, configure it to use strongly consistent reads. But by default, it's eventually consistent. And this means that when you read data from the table, it may not reflect the status of a recently completed write operation. But if you use strongly consistent, then this will reflect all previous writes that were successfully completed. Access control is controlled using identity access management policies. And remember, in the lab, we used an IAM service role with the DynamoDB full access policy to allow our EC2 instance to interact with DynamoDB. And when we deleted that role, the EC2 instance could no longer query the database. Remember, we can use fine-grained access control using the identity access management condition parameter, and that is called DynamoDB leading keys. And we can use that to allow users to access only the items where the partition key value matches their own user ID. Indexes enable fast queries on specific data columns and give you a different view of your data based on an alternative partition key or partition key and sort key combination. But it's important to understand the differences between a local secondary index and a global secondary index. So just remember, for the local secondary index, this must be created when you create your table. It has the same partition key as your table, but a different sort key. Whereas the global secondary index, you can create that at any time, either at table creation time or any time afterwards. And it can have a different partition key as well as a different sort key. You can use a query operation to find items in the table using only the primary key attribute. So you provide the primary key name and a distinct value to search for. For example, the primary key name of user ID and the value of the user ID, for example, 201. Alternatively, a scan operation examines every item in the table. By default, it returns all data attributes, but you can use the projection expression parameter to refine your results. And from the console, you can use the filter function. Query results are always sorted by the sort key, if there is one, and they're sorted in ascending order, so 1, 2, 3, 4, etc. And you can set the scan index forward parameter to false if you want to reverse the order. And remember, this is for queries only, it's not for scans, even though it's very misleading that they've called it scan index forward. Just remember, it's only for queries. And in general, the query operation tends to be more efficient than a scan. If you want to improve the performance of queries and scans, you can do that by setting a smaller page size, which uses up fewer read operations because it returns a smaller set of results. You can also isolate your scan operations to specific tables and segregate them from your mission-critical traffic. Alternatively, you can try parallel scans rather than the default sequential scan. However, in general, you should avoid using scan operations if you can. Instead, design your tables so that you can use the query, get, or batch get item APIs. DynamoDB throughput is measured in capacity units. And remember, one write capacity unit is equal to one kilobyte write per second. One read capacity unit is equal to 1 4 kilobyte strongly consistent read per second, or 2 4 kilobyte eventually consistent reads per second. In order to calculate your write capacity requirements, first calculate how many capacity units needed for each write. So you would take the size of each item, and in this case it's 512 bytes, divided by 1 kilobyte for write capacity units equals 0.5. Round that up to the nearest whole number, and each write will need 1 write capacity unit per write operation. Then multiply that by the number of writes you need per second. So 1 times 100 equals 1 write capacity units required for this example. In order to calculate your read capacity requirements, first calculate how many capacity units needed for each read. So in order to read 83 kilobyte items per second, you take the size of each item, so 3 kilobytes, divide it by 4 kilobytes for the read capacity units, so that equals 0.75, round up to the nearest whole number, so each read will need 1 read capacity unit per operation, multiply that by the number of reads per second, so times 80 equals 80 read capacity units for strongly consistent reads. However, if eventual consistency is acceptable, and your application is going to use eventual consistency, just divide that 80 by 2, which is 40, so 40 read capacity units required for eventual consistency. DynamoDB Accelerator, or DAX, provides in-memory caching for DynamoDB tables, improves the response times for eventually consistent reads only. You point your API calls to the DAX cluster instead of your table, and if the item you're querying is in the cache, DAX will return it. Otherwise, it will perform an eventually consistent get item operation to your DynamoDB table. And it's most suitable for read-intensive applications. It's not suitable for write-intensive or applications that require strongly consistent reads. Moving on to Elasticache. Remember, Elasticache is an in-memory cache which sits between your application and database, and that could be either your DynamoDB database or any RDS database. There are 2 different caching strategies, lazy loading and write-through. Remember, lazy loading only caches the data when it's requested, and it means Elasticache node failures are not fatal. It just means you'll get lots of cache misses until the cache is built up again. And you do get a cache miss penalty, so there's an overhead to the initial request query database and writing to the cache as well if the data is not in the cache already. And you can avoid stale data by implementing a time to live. The other caching strategy is called write-through, and this writes data into the cache whenever there is a change in the database. This means the data is never stale, but there is a write penalty because each write involves a write to the database and a write to the cache. And an Elasticache node failure means that data is missing in the cache until it's added or updated in the database. And you do have the disadvantage of wasted resources if most of the data in your database is never accessed. So that is the end of this section. Well done for completing this section, and if you have any questions, please let me know. Otherwise, please feel free to move on to the next lecture. Thank you.